The next implication that we want to show, that if we happen to know that f is path independent, then the work done around any closed curve has to be 0. So what we're going to do is we're going to say, let's calculate the work done for any such path. Remember just what the picture looks like. We have a closed curve, that's C. What I'm going to do is just pick 2 points on the curve. A curve certainly has 2 points. I'm going to call this one P. I'm going to call this one Q. One path from P to Q, I'm going to call C1, and that's just the curve that goes along the side. Then I'm going to take the other path. There's going to be another path, goes around like this. I'm going to call that C2. And what path independence exactly means is that the work done along C1 is going to be exactly the same as the work done along C2. And now we're just going to rewrite stuff until we get our conclusion. I'm going to subtract, they're not equal 0. I'm going to subtract the integral from along C2 from both sides. So I'm going to get the work done along C1, f dot dr, minus the work done along C2 of f dot dr equals 0. Now, this is the work done along C2, and we have a minus sign in front of it. If we do this, so I'm leaving C1 as is, and I say, let's look at the work done along C2. In fact, I want minus C2. What is minus C2? Minus C2 is the same amount of work, we're just going backwards, right? So what we're doing here is we're now calculating, and here we're getting 0. I'm calculating the work done along C1, like this, and then I'm doing the work along minus C2, which just does this, and that's just the closed curve C. So instead of writing down the work done along C1 plus the work done along C2 backwards, I'm going to rewrite this as C1 minus C2. We introduced that notation in one of the videos, so I'm going to get that. But C1 minus C2 is a curve. It's C1 forward and then C2 backwards. Well, that's the closed curve C. So instead of writing the work done by the vector field along C1 minus C2, I can say that's exactly the same as the work done along C, because C1 is C1 minus C2. And I get that the work done along that closed curve is 0. In other words, if the vector field is path independent, and I want to calculate the work done along a closed curve, I just pick 2 points P and Q. The work done forward along C1 has to be the same as the work done forward along C2. That's just going to tell me that the work done along C1 forward minus the work done along C2 is going to be 0. And that's exactly what we mean when we say calculate the work done around the whole closed curve. And so we get that if f is path independent, then the work done around any closed curve is going to be 0.